What if I told you that matching socks is harder for AI than playing chess? As an engineer studying robotics, I've discovered why this simple task might be the real Turing test for artificial intelligence. The answer reveals something fascinating about both human and machine intelligence. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist, and I'm creating the AI Capitalist channel to talk to the leaders and the thinkers like you about how we navigate this new world of thinking machines. The thought of having robots tackle all sorts of chores, from taking clothes out of the dryer to folding laundry and clearing off a messy table, was always felt like something straight out of a sci-fi movie or a cartoon. Remember Rosie from the Jetsons? That was the classic example from back in the 60s. But a startup in San Francisco called Physical Intelligence is making our sci-fi dreams a reality. They've got this AI that's been trained in a huge amount of data, and they can do a bunch of handy household chores, like all the stuff that we used to wish we didn't have to do. It looks like having robots to help out at home might be closer than we think. Now, this achievement opens the door to making something as versatile as AI models like ChatGPT a reality in our everyday lives in a physical sense. The rise of large language models, which are basically algorithms that ingest text from books and the internet, has really boosted the chatbot's abilities. Physical intelligence is all about bringing that same kind of smarts to the physical world by feeding their algorithm loads of robotic data instead. The physical intelligence model employs a versatile approach, utilizing data from a diverse array of robot types and configurations, and it resembles the method used in training language models. The company's been busy for the last 8 months working on their foundation model, which they've named Pi 0. To get it ready, they fed it loads of data from all kinds of robots doing different household tasks. And they even have people remotely control the robots to help teach them how to do the tasks. Physical intelligence, or PI for short, is trying to take a new angle on the robotics. It's about some of the progress that we've seen in AI's language skills. They're training on more data than any other robotics model out there, and it's really makes a big difference. It's not quite like the same as ChatGPT, but you could say it's kind of in the ballpark of ChatGPT-1, which was the first large language model that was created by OpenAI back in 2018. At least according to the videos that they've released so far, physical intelligence robots can be seen tackling everyday chores and pretty much nailing it. There's a wheeled robot that rolls right up to the dryer and then pulls out the clothes like it's no big deal, and there's a robot arm that clears off the table stuffed with cups and plates. So there's another with a couple of robot arms that actually grab and fold laundry. Cherry on top, their algorithm even has taught a robot how to build a cardboard box where it gently bends the sides and fits all the pieces together. Now this got me thinking, when we look at verbal and artistic artificial intelligence like ChatGPT or Midjourney, we have a battery of benchmark tests that we subject them to in order to be able to measure their performance. But in the home service industry, what would a proper Turing test be? Personally, I've always thought that if a robot could go through a basket of socks and differentiate them all by size, match them up, assign them to each member of the household, and then use the dexterity to ball them up properly, we would have achieved artificial homekeeper intelligence. But as it turns out, folding toast is a tough nut to crack. It's all about those general smarts that they need when dealing with all the different fabrics which can bend and crumple in unexpected ways. The algorithm shows some pretty relatable human moves, like giving t-shirts and shorts a good shake to make them nice and flat. This is behavior learned through experience, not by being taught or trained by a human being. The algorithm isn't flawless, and just like those chatbots you might use, these robots can be pretty unpredictable at times. So for instance, there was one instance where a robot went all out on loading eggs into a carton and ended up cramming it so full that they just wouldn't close. And then there was one time the robot went rogue and just threw a box off the table instead of filling it as it was ordered to. Now, what would a decent price point for a robot like this be for the general public? So I'll just run a quick calculation. At least in my area, a once weekly cleaning service goes for $200 a week. And if we look at this like a car with the full 6-year loan and interest rates at 7%, then the total price point comes out at $11,700. Ain't no way they're making this robot for 12 grand anytime soon. So looking at current robots like Spot, which is a sort of dog-like robot developed by Boston Dynamics, and the robot works at condition monitoring in industrial environments. So Spot, the robot, goes for $250,000 up front. So like 20 times more than what would be a decent price point for a standard suburban household. A $250,000 cleaning service with an unknown maintenance cost just isn't a good value. But if you're getting value from this episode, I'd appreciate it if you would push the like button. Thank you for helping us break out of small channel hell. Creating robots that can do a bit of everything isn't just a cool sci-fi idea, it's also a huge money-making opportunity. Even though we've made some jaw-dropping advancements in AI lately, a lot of robots are still pretty clueless and stuck in their ways. Take the ones in factories and warehouses, for example. They just follow strict routines and they don't really have the intelligence to notice what's around them or change things up as needed. There are a few industrial robots that can see and pick up things, but they're usually good for only a handful of tasks, and they aren't very agile because they lack the all-around physical intelligence. Robots that are more versatile could tackle a bunch of different industrial jobs, maybe just after a quick demo or two. They'll also have to pick up some extra skills to handle the chaos and unpredictability that comes with human homes. People are very hyped about how fast AI is progressing, and that rumor is spilling over into some serious excitement about robotics too. Tesla has hinted that their humanoid robot named Optimus could be up for grabs for around $20,000 to $25,000. So we're getting closer to that price point. And it could be able to handle a bunch of tasks by 2040. 2040 is a long time from now. I'm behind on my laundry now. In the past, trying to teach robots to handle tough tasks meant training one robot for one task, since it looked like they couldn't really learn from each other. But some new research is changing that angle. A project from Google called OpenX Embodiment in 2023 showed that with enough scale and enough tweaking, robots can actually share what they learn across different tasks. They were able to connect for learning from 22 different robots in 21 research labs. The big hurdle that physical intelligence is facing is that there just isn't as much robot data out there for training like there is for those huge language models. So the problem that they're having is that there just isn't enough data out there. We have, for large language models, we have basically from the beginning of recorded history, 5,000 years ago till now, worth of data, all the written works of the world. For robots, they've only been with us a few years. So instead of just relying on existing information, the team has had to whip up their own data and think of new and dynamic methods to make the most out of the smaller data set. To create Pi-Zero, they mixed together these vision language models, which learn from both pictures and text, with diffusion modeling, which is a trick they took from AI image generation to help them learn in a more flexible way. If we want robots to tackle any task we throw at them, they really need to level up their learning game. We've got a bit of a journey ahead, but think of what we have now as the framework showing where we're headed. Don't stop now. I have dozens more videos. This video is part of a playlist, which I'll post for you here so that you can go through and watch other videos that are similar. Or you can watch our newest videos, and we have lots of other playlists. So keep clicking, keep watching. Click over there, right there.